Hello, Cyberpart. Okay. So let me go get something to drink and then we can start. I'm back. Yo, how many people? So, hello, Lil Boo. What is a Radix tree? I'll get to that in a moment. Hello, Mycon. Afternoon, Karitan. Hello, everybody. Hello from India. Hello, Dubai. Okay. So, Lil Boo, to get more into the depths of exactly what is a Radix tree, I'm gonna do that in, let's say, the second half of the stream, because I want to do a little bit of work with this stuff above first, but not second half. It's gonna be like, I don't know, we're gonna do maybe half an hour of this thing up here, and then we're gonna switch to Radix tree stuff. But long story short, a Radix tree is a data structure that you can use to store strings, and they are stored by prefix. Like every time you put multiple strings in it, and you can use it, for example, to implement a string hash map where your keys are strings, and then every string corresponds to a value. And so a Radix tree implementation basically stores your strings into this tree structure, but every time words share the same prefix, then that gets collapsed to only storing the prefix once. So you can put a ton of words in there, and you don't pay the price for, the full string every single time. Invader Jim, thank you for the raid. Welcome. Thank you very much. So a Radix tree basically, in practice, can really be thought of one way of making a string hash map. And there's techniques for implementing it. Could it improve PHP arrays? For all you know, PHP arrays might already be implemented with a Radix tree. I honestly, genuinely do not know. Probably not. I suspect that Radix trees are probably more of a specialty data structure. Like, you can implement string hash maps, but I suspect they are more useful for more specific use cases than other approaches, though I might be wrong. Collisions? Well, collisions in a Radix tree don't really happen, because if you store the same word twice, basically in a hash map, the same key corresponds to only one value. So if you try to save the same key twice, the assumption is that you're either overriding or you're doing something wrong. So there's that. And keep in mind, you keep the entire string in memory. So it's not like you're only storing the hash. You're not storing the hash. Maybe saying that it's a string hash map gives you the wrong idea. I shouldn't say that. Maybe I should say a string map without the hash part, because there is no hashing. But it does do key value mapping. Use cases, for example, if you're implementing search, if you want to search through something like a dictionary of words, or you want to store in memory a bunch of file paths. You know how editors have file pickers that allow you to see all the files in your working directory, and you can quickly search through that. A Radix tree is one way of implementing that. Not the only way, and not the best way probably, because if you want to account for typos, for example, you will probably want something different, but they can use for that. It can be used for that. Database indexes, I believe so. Yeah, that's a good example. I think there are some databases that use Radix trees for their keys, or more precisely, I guess you can say that you can implement a Radix tree index in a database. Like, I'm thinking SQL style databases where you have like a bunch of indexes that you can create on based on what you think is best. Yeah. Okay, so here's what I want to do to start. I want to, the other day, I made an improvement. Actually, you know what? Wait. Step 0. We need to commit and publish all the ray tracing related stuff. I thought threes were used for that, and you're totally right. A Radix tree is a try, but with node compressed. So a trie usually is, as you know, as I've seen it in literature, has one node per character, which in practice is not kind of what you want. And so a Radix tree takes sections where there is no branching. So you have cat, and so you have CAT. Radix tree would compress that. So you have cat and caterpillar. CAT gets compressed into one node that contains all three characters. So it's basically a way of making trees more practical. Also, I think I've seen places where people don't give it a different name. Like they just say that the trie, or whatever you want to call this thing, can be compressed, and so they don't give it a separate name. But I've seen in practice a lot of times that people call them Radix trees. Also, I believe a trie doesn't necessarily have to store strings in any specific order. I might be wrong, but I think you can use tries also for suffix trees if you want to. So I guess the idea of saying that a Radix tree is a compressed trie implies the assumption that you want to store things by prefix and you don't want to do the suffix tree thing. But suffix trees are a little bit weird. You might think that it's kind of the same as Radix trees, just the opposite way, but no. Yes, that's exactly it. It's a trie with splits and merges, precisely. Yeah, and in practice, when you go implement this stuff, that's mostly what you have to manage. Like you have to manage when to split, when to merge, and if you support deletion, also do both these things, but like backwards, because maybe something was split and I want to merge it because the split is gone. And you kind of want to have a normalized representation, like you don't want to have empty nodes, for example. Yeah, that kind of stuff. Although then you also have practical problems when it comes to memory management, because if merging two nodes is a real lock, the real lock is not guaranteed to succeed. So that's fun. Okay, so let's commit this stuff. Git status. ga.gc day 3 and so we push this. Then I have this stuff uploaded to YouTube, but I haven't published yet, so I'm gonna publish it. Next, public, publish. Okay, so this has been published. I need to modify the README. Also, this is 6 megabytes of an image. I mean, I guess it could be worse. Can we, right, I have it here. Can we export this from peer review? If I press save, export, PNG, 2 megabytes, JPEG. There we go. Not in documents. I want it where it is. God damn it, man. Christoph, expand. There we go. We save it not super high quality so that it can, you know, be embedded. Although having the super high quality version would be cool. I'll say that. I will say that. Maybe we should do this instead of the lower quality version. Yeah, let's do the nice version, I guess. Come on, let's not be stingy. PNG 2.3 megabytes. Honestly, it's not that bad. Is it possible to generate runtime using the GPU RTX? Yes, modern GPUs have hardware dedicated to computing ray tracing, and they are particularly efficient at that. You have to use their APIs. I don't know what even those look like. So I only learned how to do this stuff on the CPU. It would probably be not impossibly complicated, but there are two problems here. One, I don't have right now. This computer is a Mac, and it doesn't have like the NVIDIA RTX stuff. Do the new Macs support ray tracing in hardware? I'm not sure. I think they have stuff for neural networks in the GPU, but I don't think they have support for ray tracing. I might be wrong. It maybe turns out that actually it's the same hardware that can be repurposed. Yeah, you can do a computer shader. Sure, you can do a computer shader no matter what your CPU does, I guess. But obviously, it's 10 times cooler if your CPU can do this stuff in real time. In any case, this is not for me right now. Let's look at the README. The final.png image. Day 2. Day 3. GPUs for the early 2000s are capable of ray tracing, RTX, etc. is only a marketing gag. Is it? I mean, games have only started doing like a ton of ray tracing only relatively recently, and it did seem to be connected to new capabilities from CPUs like extra dedicated hardware. Like in the early 2000s, you wouldn't be able to have, you know, footage that it's kind of hard to say immediately if it's computer graphics or real. So okay. So what next? So we're good with this. I don't know if anybody's interested in this stuff. I'm gonna share the link here. Bork send. There you go. Okay, we're done with this. Let's look into parsers and tokenizers. So there was this blog post that was posted like yesterday. You love my shiny balls? Thank you. Yeah, I shinied them just for you. Just for you. I think it got. Did it get on lobsters? I think it did not. Okay, let me find it 1 second. Mm, copy link. This one. Where basically this is a blog post that tells you about different tools. You know what? Let's quickly scroll through it because I think it's interesting. So here's the idea. You're on macOS and you want tools for looking at performance of your program. Good luck, because it's not as the OS doesn't make it easy for you. So you want perf, doesn't work. That's a Linux only, which, you know, fair. Valgrind doesn't support macOS on ARM64 RIP. Tracy mostly works, but call stack sampling is not supported. I don't know why you need this, or rather, sorry. I mean, I can see somebody needing this. I haven't needed this yet, and I'm not sure if I need this at all. This seems, I guess, something that you want to look at if your call stack is dynamic. My call stacks are very rarely dynamic, and when they are, the dynamicism isn't interesting. It's usually kind of obvious. But, you know, if you're writing weirdo, loopy, vtable, C++ stuff, sure, you will make insane call stacks, not realize that that's what you're doing, and then you gotta sample them to understand what your program is even doing. I will say that this seems very bad to me. Like, if you don't know what your call stack is even going to be, like, not at all, it's weird. In any case, I might be missing out. I might be missing some nuance. There might be more to this that would be interesting to have. Maybe because it allows you to look at what like values and how, like, variables, what they are as you go through the call stack. I don't know. I don't know if it even records that information. That said, looking back, thinking back at the ray tracing in one weekend stuff, they did have this weirdo thing where objects and lists of objects were both hitable, and so you're calling into this stuff and like you're calling into hit, but like which hit is it, where it's coming from, I don't know. Maybe it's more interesting. In any case, so Samply, this is a Rust thing. I don't find it super interesting because this to me looks like a worse Tracy, so I'll take Tracy. Sorry, with all due respect, I don't mean to talk bad about this stuff. It's just that, generally speaking, it's a Rust thing. I like Tracy already. So here's more interesting stuff. There's Poop, but Poop doesn't work on macOS, and so there's a fork which or rather, there's a PR that Andrew doesn't want. So Andrew doesn't want the doesn't want macOS support. According to him, he's kind of working on macOS. So apparently there's some stuff that is not working. And so this blog post points out that there is a fork that has the PR merged. And I'm kind of curious. So I actually did clone this, but I'm gonna remove it, and I messed with it, and I broke it. So remove Poop. Let's clone Poop again. Get into Poop. This is a branch. 7 commits ahead, 2 commits behind. Is this now updated for newer Zig? No, this is still 0.14. Okay, so we need Zig up 0.14.1. Zig build -- release equals fast. Oh no. Why are we looking at Zig 015? Oh, I guess because Zigup failed, didn't it? Yeah, unsuccessful response. Oh, because 0.14.1 is the old version. Oh no. Do I have 0.14.0? Yeah, I have that, so so it's not gonna have to fetch it. So now we can do this, and hopefully the patch release didn't fix anything that was critical for this. Error: root source file struct fs file has no member. Std out. Okay, somebody forgot to update this field. 0.14.1 is not the right number. Don't use lazy depths. Okay, let's look at these commits. Don't use lazy depth. Add build of scoop. Bumps. What? Dude. Why are you lying? Also, is this in scoop or is this in main? This is in fucking main, man. Okay, there's a bit of confusion here. 0.14. So, by the way, the point is fs in 0.14 does not have file.stdout. This is the writer gate stuff. This is also not gonna work because this zig is too new. Zig up list. No, bro, it's a flag. What are you doing? Okay, zig up list. Okay, we need to pick a version, a good version. So it has to be 0.15. Why are they not sorted, man? Sort them, please. Please sort them. I think this one is a good this one is a good candidate, I think. Let's see. Zig up, this one. Zig build. By the way, I'm trying to build this so I can test this stuff with do they have releases? Okay, no, they don't even have releases. God damn it. I want to test this stuff with the changes I'm making to my Zine parsers. So there's this one. Sorry, this one. Oh, this one is pre-writer gate. Okay. Okay, let's try to see if we can fix this one. Although I think there will be other issues, I suspect. 207. Function with non-void return type. In POSIX, does it reaches control flow of body ends here. So this is a bug in this version of Zig. So we need a newer one. Let's go to, oh, there's 1034. Let me try 1034. Yeah, this has the same problem. Okay, so let's go up. I think this one is post writer gate, I think. No, what am I doing? This is where I was before. No, yeah, right. It is still post writer gate, but it still has this issue. Okay, let's go up some more then. Okay, let's try this one. Hi, I decided to make it possible to observe in real time the rendering of the image by mapping the output slides to a file. Oh, nice. Yo. And how are you viewing everything then? Like what viewer are you using basically? I guess that's what I'm asking. Okay. Cool. Let's see if it works on my computer then. Oops. Do I need to pipe out or do you hardcode the file? Let's see. Oh, wait. Which version of Zig are you using? Are you on 0.14? No. Oh, you are. Yo, this is nice. How does it refresh? Does it refresh automatically? Do you think? If I resize, does it do anything? Command R. Oh, there we go. Yeah, this viewer is not really updating, is it? I mean, there are weird ways in which we convinced it to do something, but I use F5. So the problem is I don't think I have access to F5. I have a custom keyboard and I don't remember how I bound F stuff. Although I should check on that because I do need F stuff from time to time, and would be nice if I eventually got rid of this weird limitation that I have. But in any case, this is cool. Good job. Okay, let's go back to to get poop to work. So we're saying that this one doesn't work. You know, I bet you that there is no version of 0.15 that can make this work. I don't know. This one doesn't have polar.fifo. So this one is after some change. Or you know what? Actually, this might be still affected by that problem, but we're just like hitting an earlier error. Okay, this is a disaster. I was hoping to be able to use this, but there's just no way, it seems. Oh, you know what? Also, man, we could have tried to use the branch from. We're gonna try to use this branch from TensorRush, but that got deleted. So let's take a look at TensorRush. What does he have? Maybe he deleted it because he merged it into his master. Let's see. Yo, did he delete the entire fork? Okay, he deleted the entire fork. I guess he only forked it specifically for that reason. Wait, where's Scoop? I'm starting to get confused. Oh, right, it's here. Okay, did he then make poop in here? Actually, does this one have a CLI now? No, this hasn't been touched in a while. ArcZone, Scoop, ZQ, Lisa, Orga. Okay, so yeah, none of that. Okay, so the dream is dead. So we can't use poop to analyze performance characteristics of changes that I'm making to the tokenizer. At least not on macOS. That is annoying. That is really annoying. And the fact is that this shouldn't be too hard. You know what? Let me not do this. Git stash, whatever. Ooh, wait a second. This is also poop main. Wait a second. Wait a second. Oh, this is the kperf macOS branch. Oh, what about main? Main is old. Okay. Kperf macOS is new. Add macOS is also new. What is going on? What is this? The one I should be using? Is it add macOS or kperf macOS? I don't understand. I do not understand. So this is really Zig 014? Expected target found pointer. Inside scoop. Oh, you know what? This might be on me. Holy shit. It's working. Oh my god, it works. Cool. Okay, let's see. Let's try this on my tokenizers. So I'm gonna go to Scripty. So yesterday we made this change in source. We have the new tokenizer and the old tokenizer, and they have main functions for benchmarking purposes, which I tested with Hyperfine. So I'm gonna do zig build xz tokenizer.zig. And so the reason why I can do this, for the people watching who don't understand really well how a Zig project is usually built and that stuff works, you can't normally go into your project, pick out a random file and try to build it as an executable. The reason why this works is because, one, Tokenizer doesn't depend on anything on the standard library. It's the bottom of my pile of abstractions. Although, even if imported another file, that isn't necessarily a problem. But if that then imported some dependency, like a package, then that would be a problem. And also the way it works is because I gave this guy is usually meant to be imported, but I gave it a main function that just hard codes one benchmark. I should say also micro benchmark to be more precise. So that's why Zig build xz works on this. So this is tokenizer name new, and then tokenizer. And also -o release fast. Okay, so this is what the fuck am I doing? So this needs to be called old. Okay, let's try again. Also, wait a second. Zig version. Yeah, no, this is old. Zig up master. Let's switch back to new Zig. Okay, so this is old, release fast, and this is new. Okay. Now I should be able to do poop, new, old. Actually, I think the order should be old, new, error. Oh, and this needs sudo, I think. Yeah. Okay, let's see. Okay, according to poop, old versus new, there is a 30% performance improvement of wall time, small difference in PKRSS, but 38% fewer CPU cycles, 35% fewer instructions, 35% fewer cache misses, 32% fewer branch misses. Now I want to try one more change. So I'm going to copy Tokenizer and I'm going to call it Tokenizer test. And in Tokenizer test, I want to try something out. So here I'm accepting a string that doesn't have an null terminator. And I want to see how much expecting a null terminator can make a difference in performance. So here's how it works. Instead of doing tokenizer char, we do source at tokenizer.idx. And we do this for every place where we do this, we replace it. Basically, I want to see how much is it costing us not being able to assume that the string is null terminated. And it feels bad not being able to do that because you kind of feel like you're leaving performance on the table, probably a non-trivial amount. But I actually don't know that. I don't know that for sure at all. I'm assuming. But how much that is? No idea. So let's see in this case what happens. Okay, so we're gonna zig build test token test. Aren't you looking at a different branch? What do you mean? Oh, this might be. Are you lagging behind a lot? You're probably lagging behind a lot. Sorry. Yes, I was looking at a different branch back when I was doing this stuff. Yes. Sorry, when I started to build poop. Test. Okay, we build test. And let's raise that also against the others. So let's add to poop old, new, and test. So it seems to be better. It seems to be better by a non-trivial amount. Let's raise new and test by themselves. Let's see how much they do against one another. So now new is the baseline. God damn it, there's a 10% difference. That sucks. To be fair, this is a 10% difference over nothing. In practice, this difference when you're like building a zine website is something that you would absolutely not be able to feel. There is no way. It's probably, this turns into a fraction probably of a nanosecond. I think it's like, well, maybe not fraction of a nanosecond, but it's like a few nanoseconds at worst. Here, by the way, keep in mind, we are in the scale of milliseconds because the benchmark is tokenizing an expression a million times. So that's why this is in this order of magnitude. Because otherwise, if your benchmark is not beefy at all, then your measurements are like pretty much noise all the time. So, but in any case, I think you wouldn't feel this much. That said, it is true that there is a non-insignificant difference between being able to assume a null terminator and not being able to assume a null terminator. And yeah, that is bad. It is bad. So, good to know. Still, this is not not terrible. So let's remove tokenizer test. I think this is still fine. Where's test.o? Why did test not produce test.o? Anyway. So what do I want to do next about this? I think I'm honestly kind of happy with this. There's obviously a lot more work that needs to be done with Scripty. Maybe I should write a README for this guy. We never wrote a README. People don't know how to use it. Maybe we should explain to them how to use it and make a maybe even an example directory that they can use as a starting point. That would probably be nice. And then we can also use this as an opportunity to start formalizing what we really want the interface to be. Let's see, this is 4 p.m. You know what? I think we can leave this for the next time. Let's consider this done and let's move into the Radix 3 stuff. I think this is going to be more interesting. So let's go do that. Okay. So CD. So I should have, do I have it here? Something about racks. Is it in documents? There's no racks anything. Although I think I didn't know I have this. Do I have any Zig racks in here? I might have never published it because it was never particularly good. My previous attempt. Oh, there we go. Maybe I did do it all, but it wasn't as performant. I think it wasn't as performant for sure because I ended up doing things in a way that was definitely suboptimal. Let's take a look at a node. Where's the Rax node? Oh, it's it's in node. The Rax node, yeah, look at this. Layout is it's a tagged union. Can either be compressed or branching. And yeah, this is nowhere near as good as the C code. Please tell me that nobody cared about this stuff. Thankfully, nobody did really care. So this is okay. I think we might very well just reset this repo. Like reset it entirely, like delete the entire history and just redo everything from scratch. But I have 4 stars. Am I going to give up 4 stars for a hard reset, or do we just reset the history? You know what? Maybe we just reset the history. We don't lose 4 stars. I'm joking. I don't even care much about that. But git clone Rax git switch -c main cd Rax switch main. How do we reset the entire history though? Git reset entire history. I guess we can do this. Maybe we can do we look at the README. We modify it like this. I was about to say, oh, you know what? We can do git rebase. Those are the last 5 commits. And we delete. We drop all commits. Does it work? Invalid upstream. What does it valid upstream mean? Does this mean that there are no 5 commits? Git start new branch. Empty, something like this. Orphan. Option orphan requires a value. Yes. Fatal invalid reference main. Oh, I guess it's not -c. It's just -orphan. Switch to new branch main. Okay. And it's empty. Okay. So touch. I will copy to Chris RTX license to license. There we go. Make a README. Then zig init. Should we do a minimal init or should we do a beefy init? I think a beefy init is fine. Then we look into the zone file. Yeah, no, this is so bad. Look, to change this to racks, now I need to regenerate the value. That sucks. Yeah. Okay. So next. I guess we have the basics now. But also, before we get into the Radix 3 proper, we have another duty, which is explore this design from Andrew Kravsky. So here's the idea. Also, related to this, let's take a look for a moment at the discussion on Zigit, because that was also interesting. So let's see. Just wanted to share a goldmine for Linux enthusiasts. Let's see. Maple Circuits channel is a goldmine for anyone who wants to get a condensed kernel news update for everything that's coming. 100 times X more convenient than going on scavenging LKML. Nice. I don't really care about updates to the Linux kernel that much, but maybe I should. Maybe there is cool stuff coming to the Linux kernel and I should worry about it. In any case, so this all started with this blog post and code and design from Tristan Pemble. I read already the blog post the other day, so I'm not going to go through it again, but I'm just going to look at the API. So he has this approach where what he creates, I think this should show what type of slice it creates in the README. I think that would be nice. I'm going to pull that from the blog post then. So he creates basically this data structure where you have, where you specify that your struct has a bunch of resizable array fields, which I think he renamed to flexible array. And then the lengths of these things get stored in a slice. But here's the interesting thing. Andrew, by the way, I don't know if you do read Zigit, but I posted there about your work. And you know what I realized? That the one key difference between your approach and the approach from Tristan Pemble is that he stores length information next to the pointer. So when you have a pointer to one of these things, you have a slice, a structure slice, which is a great name for it, and that is a key piece of information that you can't lose. Like the slice, the fat pointer, or as the helpful commenter on Hacker News said, the obese pointer contains key information that you need to have. When implementing a Radix 3 data structure like this, you can't use that approach because you need to have the length information be here in the heap allocation. Otherwise, there's information missing. And at that point, you need to heap allocate the slice. And that's just not feasible. So, So if we want to replicate this design, and by the way, the point is the assumption here is that we want to replicate this design. That is not necessarily the truth if what you want to do is create a new implementation of a Radix data structure. You could make one that uses that other approach. Maybe it's a good idea, maybe it's not. Definitely you can't do it the same way. It would have to be something different, and you would have to pay the price of having those lengths not be on the heap allocation. But then maybe you could use that to your advantage if you're smart about it. So, there's all this stuff that it's a little bit up to debate. You probably would not be able to really gain much from that, I suspect. In any case, so your approach instead does put stuff on the heap. So your approach is definitely more suitable for what Rax is doing. So let's try to flesh this idea. I'm gonna make a repo for this work. Oh, you know what? Maybe this should be zig-flexible array. So we can do zig init. I think here we can do it minimal. The problem now is that, God damn it. God damn it. God damn it. Zigzag array. You know what? They should be renamed to zigflex. RM. Move. You should call zigflex. You want to import flex. You don't want to import anything more complicated than that. Zig build. Complain about it. Copy. Okay. Let's rename this again. Zigflex. Rename. Yes, it's available. I know it's my thing. Let's go. Okay. Zigflex. Then mkdir source dot hx source slash root dot zig. Copy. Okay. So here we have flexible array, blah, 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 and we have a working test. How are we doing with this stuff? Build system. Mod equals b.add module. Flex. Root source file is b.path/root.zig. What else do we care about? I guess target options. Is it optimized? I think this is it. And use local constant, but I'm using it. What do you want? Like build, test. Okay, it runs and it prints stuff. Is it supposed to print stuff? Let's take a look. Yeah, well, yeah, it definitely prints. But it doesn't print what it should be printing. This should be printing other stuff, shouldn't it? Wait a second, what's going on? Okay, let's take a look at the code. Code sets ID, hash, name, and label to these values. Then we make a buffer. We make a fixed writer for it. We write down these guys. Then we cast the buffer to a packet. And then we do test equals slices. Oh, wait a second. Right, the test is testing. The test is not outputting anything. We are seeing. We were seeing some other debug prints. Yeah, we were seeing these debug print. Okay. So it seems fine. We are passing the test. Yeah. Maybe we can even test that the test fails. Let's make the test fail on purpose. Poop. Yeah, there we go. It doesn't say poop. It does say Andrew. Perfect. So we're passing. Okay. So flexible array, huh? Okay, how would I do this? Also, this definition, I think, should go inside the test. First, this can be a normal struct and it should still work. Does it? It does. Then I think we should account also for packed structs. If we want this to work with racks, we need to support packed structs. So here's what I would say. I think the flexible array should accept one extra parameter. And the extra parameter should say the extra parameter should say the type that we want to use to store the length of this guy, and it should special case use0, where use0 means this guy is not empty. This guy will have fields, but it's going to be external. Although, you know what, we can say this even without special casing use0. Like we can make it more expressive. Yeah, we can definitely make this more expressive. And then what is the point? The point, I guess, let's make a test of what we want to make happen. Is this flexible array type safe? Ish, yes, I think. The implementation requires you to do bit fiddling, but then if it's implemented correctly, then you use it and it is type safe-ish. I mean, as long as you don't assume that as long as you don't try to cast random memory to a pointer to a packet, and if you don't get that wrong, which right now we're doing manually, but the idea is that there should be an API that gives you this, and so at that point you should all be fine. You get bytes from it though. You get bytes from it, do you? I mean, you get a slice. From it you get a slice, but it's not a slice of bytes. It's a slice of. Oh, actually, wait. This, yeah, okay. So here it's hard coded as a U8. Yes, this needs to be parameterized. So this needs to return the type T of the field. So this needs to be improved. Okay, my idea is this: const racks node is a packed struct. So this is what I would like to make work with this. What is it? Is key bool is null bool layout is a u1 enum that can be either merge split, and then it has a length. I'm gonna put len, and this is a u29, right? Because it's 1, 2, 3 bits. u29, 30, 31, 32. So it's 32 bit. And then we have the flexible members. So we have well, actually no, it wouldn't be like this. We have then chars. Although chars is a bad name, let's call it bytes. And this is a flexible array. Oh, you have to pass out also the name. Right, you have to do this. There's just no other way. Flexible array. Although I think you can also do this. And then you say, what should this guy be? Maybe we can do this. Hopefully, packed being a keyword is gonna fuck us up, isn't it? Maybe no. We'll see. So we can say packed and then u29. And then the last one is pointers. And this is going to be... we need a main for... we need a name for this idea. Basically, the idea is that for this one, we do not store the length. So we can say this is many unmanaged. Let's go with unmanaged for now. Okay, packed as a keyword here is bad. But we can also do it like this, just managed and then unmanaged. Okay, so this is what we want to be able to work with. And this, in this case, is going to be name, and then this is going to be managed. You know what? Maybe this is a little bit too verbose. We can just do U29, and this one we can do null. And then we accept like an optional type. So name is going to be usize, and this is going to be usize. Okay, let's see if we can do this dot name. This is really funny, by the way. This is like exploiting Zig's laziness like to the fucking max. Okay. Why did you repeat name in bytes? Because this instance of flexible array, to be able to get information about itself, it needs to know which field it is in the parent struct. And if I don't pass this information down, then it has just no way of knowing which it is. Not only that, but also, sorry, in fact, that's a good point. This needs to be label. And this needs, and this needs to be PTRs. That was me failing to update the copy paste. And they also need to be, they need to be different because you concretely need this to be two different generic instantiations of this, I believe. Let me think about it for a second. Yeah. I think there's probably a way of reducing the amount of generic stuff and at some point turn everything into a type arrays implementation, but this we can worry about that later on. Okay, let's try to, we have now broken this test. Let's try to make it work again. So is this a struct or a packed struct? I think we should return a packed struct no matter what, because we can, I believe you can always put a packed struct in a normal struct, but you can't do the opposite. And making this packed, I think it's a good idea. Then what I would say is that this guy should have, I think, a field in it, which is the length. And it should, the type of length should be based on this. So that you can do name.len if you want. This should work. There's no reason why this shouldn't work. So we can do this. Len is what? So comp time name. This is now something different. Can we say enum literal? How do you accept an enum literal? Well, you do want it type though. Okay, let's do any type for now. We can do better though. And then we have len type, I guess. Although it's a type, so it should be camel case. So len, and it's a type. And then we would need some comp time tests about type. For now, well, we can do it. We can do this. If type info of len is different than dot integer, then we complain. Len must be an integer type. Even put that on a single line. Okay, and then we say that len is of type len. Then, oh, also this is optional. Non-zero unsigned integer. Let's see. Let's see what the signatures, the docs should be. Provide P is the parent type. Provide it. Well, usually provided via at type info. Sorry, at this. Name is the field name is an enum literal matching the field name so you have const foo equals struct flexible array this dot bar and then use size. Yeah. When a flexible array has no len, then the slice function will request length information as an input. So we could have a different implementation of slice that gets that forces you to provide a length information. Alternatively, we could just make it return a multi-pointer. And honestly, making it return a multi-pointer is probably better. And then you as the user decide how to slice this stuff or not. It's yeah, you know what? I think I prefer that. The slice function will so we kind of would like to avoid having len in the first place because it's kind of misleading, the fact that you can even do .len. It would be better if you could avoid that. The problem is that if we start doing that kind of bullshit, then we're not going to be able to give it a slice anymore. This is sucky. This is sucky. Also, you know what? No, if we put it as a use 0, then also people would be able to like use it. I think you would be able to slice using this value. I might be wrong. Yeah, because it would be just a 0. I think potentially. So Let's just make this either void or extract. Void. I think making it void is the solution in this case. How would you construct a struct with flexible array? You're looking here at the example. That's how you do it. This is what you would be... Or are you talking about like, okay, this is how you define it. If your question is how would you initialize it, that's what I'm going to implement next. Yeah. This is what I'm going to work on next. Okay, so this needs to be like this. Const. When this increases the size power struct, it does. So you do add a length field if you pass in something like usize. If it's null, then it won't, because this packed struct contains a void field has length 0. Oh, thank you. Okay. So you know what? We can call this len or void. This is now len or void. So this works. Len must be an integer type or null. Then let's see. Len is len or void. Then we need to give it something to recognize it for metaprogramming purposes. So so Andrew had this, which makes total sense, is flexible array. I guess this works. We can give it as is. I'm tempted to do something more like I think this also should be pub. Wait, do we even have the ability to see this through reflection? We have to, otherwise this wouldn't work. That surprises me, even if we don't make it pub. That's cool. So the metaprogramming then is able to see non-pub stuff if we are in the same file. That is cool. I didn't know that there was this difference. Very cool. Okay. So we have our hidden token that says if we are in a flexible array, we have slice. Slice accepts our type, and now we need to decide the return type. I think we can compute the return type here. Const return type is if len or void is void, then we return a many pointer of type T, which we don't know yet. Wait a second, we're missing something. We're missing the type of this thing. Wait, this was implicitly bytes up until now. We need to say which type this thing is. So we need an extra argument. I forgot that we also need that. This signature sucks. We should be able to do better. And I know that I can't put any type in abstract, so we're gonna have to solve this later. Okay, so but we need to do this, I think. So instead of doing this, we do options, and then we do T type. Okay. You know what? Maybe name can be a string. Let me think about it for a moment. We could leave it as a string in options so that we don't have to make options generic as well. I think there is, though, a way of saying, I think we can do this, right? I think we can do this. This is what I was looking for. Yeah, I think we can just leave it at that, and this will work. And this is much more sexy. And now I think some of these docs can be split, basically. Okay, I don't know what to do with the example yet. So for now, I'm just going to leave this here. So flexible array. Yeah, this is so much nicer. So now we don't go insane with this type signature, and it highlights the important stuff. And now we can even give defaults to these values. So type we can't, name we can't, len we can give it a default. We can make it by default usize, so that people don't specify it and they get what they would normally want. Okay, so now if ops.len l blah 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 integer blah blah or void, return type now is len or void equals void pointer t, otherwise blah blah blah. So now slice returns return type. I have already tests down there, so I'm gonna update them once I make some progress with this implementation. So but you know what? Maybe we can do it here. Okay, yeah. So this would be like this then. Bytes would be U8, and then dot up, and then it would be like this. It would be this. The name would be this. Dot len would be this. Yeah, this is annoying. This doesn't work because I'm defining this in a function body. But if I define this outside, then it works. So there you go. So this is how it would look like. Flexible array, the type, then all the options. The type, then all the options. Notice the recursiveness. This is gonna stress Zig's lazy evaluation real good. So this wouldn't work. Yeah, it would work. It would totally work. But I wanted to make it look nice. That said, yeah. There you go. But here's the thing. Bytes, we want length U29. Pointers, we want null. We want this to be null. Or you know what? We could have, instead of making this optional, we could make this accept a void. So like we tell people, you put void if you don't want to store length. But then I don't know. For now, let's do the null thing. Then we can change our mind later. I guess it's not a major thing. Okay, so this is how it looks like. Then so slice says it's a pointer to itself. Yes. Parent p. We can make also this const p equals ops.parent. So p is this const name. Name equals tag name of ops.name. Let's do it this way also. Okay, so this works. Bytes is, let's see, start line of p u8 pointer cast parent. Yes. Why are we going to the parent? let's see what are we doing. We set offset to 0, right? And then we do some math. Then for each field, we're adding stuff. But I think we can do better than this. I think we can say our starting offset is at size of, I think we can do this, right? Size of P is going to be where P ends. Sorry, where the main struct ends. In this case, this refers to which struct? The struct definition. So when you do this, this refers to the nearest struct definition. So look for the nearest struct key, or like union or enum. So when you're defining like a container. So the fact that you're in a function, or the fact that you are inside in this case, the fact that you are inside a struct instance. Here we're not defining a struct. Here we are creating we are instantiating a struct. So this is the closest definition of a struct that we have, and so this will go here, and this also will go here. Will correspond to this. If you do have nested stuff, like sometimes you nest structs definitions, and you need a reference to the one outside, you need to create a decal for it. So don't get confused. This is not a struct definition. This is a struct literal. This is a struct definition. Okay, so I think we can start from size of P, and then we still need to loop, but we only care about flexible arrays. So the idea is also, here's another check that we need to do. If we want to set this to void, we need to check that this is the last field. So the assumption is that only the last field can be null. So we need to test for this. How do we do this? We need type info of the parent. And what we want to say is, well, we expect the parent to be a struct, right? This has to be a struct. And I'm asserting here, so this is the line that's gonna blow up if this is not true. And I'm basically expecting this comment to be what people see. It's kind of this, except relying on a different mechanism. So it's the information that gets shown to the user. So we do pinfo dot fields. What's in here? Can we go to definition? Of course we can't. Can I go to definition on any of these things? No. STD built-in. There we go. Type, blah, 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 blah. Or struct. Struct. Okay, I look into fields. I look into fields and I care about, I look into the last field. That's what I want. So fields at pinfo.fields.len -1, and we need to check that this dot type equals this. This has to be us. Yeah, this is shitty. This is kind of telling us that we want to use void. In any case, I'm gonna look into this later. Okay, let's explore more. So this seems good. So the idea is we want to loop on all fields until we encounter ourselves, and we keep adding stuff. We keep adding lengths until it's us. Let's see. I've done it again. Yeah, I keep doing it, don't I? Thank you. Oh no, it's like this now. Right. So for each parent info field, we grab the value. No, we do this. If pinfo, if field dot type. I think we need like a quick way of saying is flexible array, which I guess it's this. So something like this. If it's not this, let's see, type info of value. So this goes here. Type of value. No, we do this with if field dot type. I think field has type. Yep. So if field dot type, if type info field dot type is different than struct and is and as decal dot type flexible array. So if not is flexible, continue. Okay. And then this case doesn't happen because we compute all of them all at once. So these guys are the ones that remain. I think it's because type is not a keyword. Or you know what? I might be wrong. Maybe I can't do this, and maybe I'm gonna need the quotes. We'll see. Well, we'll see. In any case, to do length is bitcast bytes starting from offset. We don't need to do this anymore. We don't need to do this anymore because this is done for us. This is literally, well, this is literally value. So the value is literally the length. So we do offset plus equals value. What is this len here? Oh, in case that once we like reach ourselves, what happens there? And we use that for slicing. Yeah, we can't do that anymore. So we have to resolve everything right away. We have to resolve everything in here. So let's see. We keep adding to offset. What was I doing? This is, yeah, this we don't need. Then we say, okay, so then we keep adding until we find ourselves. And when we find ourselves, this is where we need to end. So, how does it work? We need to check our type. So we switch on our type, right? We say, or well, not necessarily switch, but like we branch on the type of flexible thing that we are. Also, bytes right now is not being used, but yeah, we should. Okay, so here's how it works. Also, we need to keep in mind alignment. The type T has an alignment, so we need also to keep in mind that. Yeah, we need to add this. And then we need to say, oh, yeah, I don't know how to compute alignment stuff in here. We need extra sophistication for dealing with alignment. Okay, I'm gonna think about it later. Let's do for some main pass. Okay, we encounter ourselves, and then we can be a thing that has a length. So let's say that if we have a length. Will plus equals work for flexible array? No, you're right. We need to do value.len. Thank you. We need this. And I really think that we should use void as a convention for saying that length is dealt with outside. Okay. So we can say this: if len or void is void, then here's what we do. We go to where we are, and we need to return bytes from offset, starting from offset, going forward, but we don't know how much forward. And this, I believe, should return a... oh, what is this type? A line of P, U8. This is correct. This is correct. This is correct, I believe. Also, we need to do this, sorry, times size of field.type. Because we need to go forward multiple bytes. If it's a U8, then yeah, it's just the length. But if these things are not U8, like there's something bigger, then we need to go forward their size. And this is it. With one caveat. We need to pointer cast this because this is going to be an array of bytes, and this needs to be something else. So can we just pointer cast? We can try. I don't know if this will be liked by the type system. It might not be liked. We'll see. Okay, what if len or void is not void? So there is a length. Then, oh, wait a second. We actually have a problem here. Because we keep doing this in a loop. And times of field of type. That is indeed a good point, isn't it? Yeah, no, this is wrong. It needs to be like this. It needs to be like this. We need to save information about the child type. Thank you. That was accurate. Yeah, we need to keep around the child size of all these, of all of us, in a sense. And that's what we need to use here. Thank you. Then in here, hopefully the pointer cast works. So if instead, okay, I just realized that there's another wrong thing. We're doing the math a little bit too early because if we find ourselves, if we have found ourselves, then we don't want to do this addition math so quickly. And more importantly, even before checking if we are void or not. So this goes here. And if we have encountered ourselves, then what we do here is return bytes from offset going forward, but up until I think it's like this. Bytes to slice value, bytes as value. Bytes as value? No, that's not exactly it. Well, you know what? It actually doesn't matter because we can do this. So this is a pointer, and we pointer cast. And then we return items sliced to from 0 to value.len. So we put this here because we're gonna need it. I think this is how it should be. So let's do one final loop. We grab a pointer to the parent. We cast everything to a unknown length slice of bytes. We start from where the struct ends. We start from the end of the header, basically. And the reason why this is very different from before is because Andrew did not put these fields here. For Andrew, these were empty structs, but instead now I'm putting the length here. So we start from the end of there. We loop over all fields. If the field is not a flexible member, we don't care because we already accounted for all of them in this count. Then as we encounter flexible fields, we know that we're going to need to move forward for how many items are there. And we want to stop it ourselves. So if we encounter one, which is not ourselves, then we grab this value and we push forward offset by that many items times the size of the children of that flexible field. Then, if instead we do encounter ourselves, then we have to worry about being void or not. We don't worry about checking for void before encountering ourselves because only the last one will be void. So it's impossible to encounter a void before encountering ourselves, if that makes sense. Then, if it is us and we are a void, then we just pointer cast up to where we got to a mini pointer of our child type, which is our return type here. If instead we are not a void type, then we still make this. I guess, you know what, since that we're doing this no matter what, we can do it once and then we can return items. And we can actually remove this and remove this nice early exit condition. Otherwise, we return items, but sliced more. Are multi-pointers and slices compatible? No, they're not. But we're gonna flip the return type based on this logic here. So we're going to basically, using comp-time metaprogramming, we're either gonna implicitly omit this line or implicitly omit this line. They're never gonna. This is comp-time branching. So we're either gonna have one alive or the other alive, never both. We can even do this, in a more explicit way. Okay, this seems fine. There is only one mistake. It is not accounting for alignment. The only mistake that we're making is not accounting for alignment. This might bite us in the butt for complicated thingies, but this should be fine for simple thingies. So I don't know. Let's see how far we go with this. Now, here's another missing piece of the puzzle. How do we create one of these guys? Because Andrew in his code had, well, a bunch of manual instantiation. So we need something nice. We need basically a convenience function that takes in our type, a GPA, and some counts, some length counts, so that we can create an instance of this bad boy. So this is flexible array, and then with options, and then we probably want another function afterwards. I don't know what we should call it. Any suggestions? Init. Well, but init doesn't imply heap allocation. I think it's create that implies heap allocation for us, doesn't it? So create parent type, then GPA, and then counts. And what is counts? Counts needs to be a... We can make it any type, I guess. This would be, I think, a reasonable way of using any type. I thought about it, and I think a nice way would be to create a helper function which accepts type and accepts an obese struct. Yeah. That's basically my counts thing. Yep. I think leaving it non-typed would still be fine. Maybe. Okay, give me a sec. I'm going to take a very, very quick button break. Then I'm going to implement this. And then we should be able to try this stuff out and see if we can make that test work. I'll be right back. Okay, where were we? Du-du-du-du-du. You can generate the Ubisoft struct type from type and accept it. Much better experience. The problem is that, yeah, I could do that, but the problem is that it's still a type generated through metaprogramming. So it's not like that users would have a lot of visibility into it. What they would see is that it's a type that gets generated programmatically. Might as well make it any type, in my opinion, and duck type it and like explain it in the docs what's expected to be. Creates an instance of a struct with flexible array members, flexible array fields. Put a comment here and we say a struct that contains a field for each flexible array field in P. Each field contains a struct that contains a field for each flexible each field lengths. Man, I'm so bad at explaining what it is supposed to be. I'm really right now. I'm like brain farting real hard on doc strings. Like brain farting super real hard. Well, let's leave it at that. Okay. So what do we do with this stuff? So what we want is const mem is, well, not mem, bytes, I guess, is gpa dot create. I think we need like create. No, it's alloc. Alloc with options. I think. Yeah. So type bytes. We always allocate bytes. How many? And we need to do the count. Const n equals, I don't know, 20 for now. Then we need to do the count. So n. Optional alignment. That's dot of p. Then optional sentinel. Ooh. Ooh. We could support Sentinel. We could support a Sentinel. Yeah, we could support a Sentinel. That is true. Well, you know what? That's maybe an enhancement for the future. No, for now, no Sentinels. Okay. So we have bytes. . No. Oh my God. Andrew, this is actually kinda so obvious. Look, you were saying you can generate an obese struct type from type and accept it. And I was saying, I can make it any type. If only we already had a type somewhere that contained a bunch of len fields, one per each flexible array member field, which also made sure to use the correct type in there, and also made sure that the void field would you wouldn't be able to assign a number to it. If only we had a type that already had this information in it. What could it be? What could it be, huh? What could it be? Oh, but you know what? No, never mind. Because I take this back. We were. This is really close to being good. The only problem is that if we do have a flexible array field at the end, then you will not be able to put its length in here because this is void. This is expected to be void. So you're not going to be able to communicate anything about that. And that is actually bad. So maybe this is fine. So we have bytes. Okay, now we need to... I think we can just straight up return this stuff. So this is going to be our last step. Okay, let's compute n. So we have header size, and it's size of p. Then we have then we need to have we need to do metaprogramming, right? We basically need this again. Now we find flexible fields, and then we basically say if not as decal if not has decal lengths what field.name compile error Okay, so we do some validation there. And then we say size plus equals length dot, well, dot nothing, at field length field dot name. Okay, and with this we keep summing everything. There you go. And with this we force everything to be there. Length is missing. Blah blah blah. Yeah, the only problem is we should keep in mind what is the last flexible field that we found. And we need to know if we need to align forward, I think. We need to know, what is the pointer where the previous flexible array field ends, and we need to align that forward to the alignment of our type, both when scanning, so we add that to offset, and both when allocating, we add that to size. And clearly with this, we are absolutely losing, we don't have resize. So we don't know how to resize at the moment. But you know what? This is already a starting point. Okay, let's see if this works. Like, let's start running through compile errors, I guess. Let's see if we can make this work. So how would this be reworked? So this reworked would be U8, and then parent is this, name is this. And label is the same label. Then so here we have a buffer. But we don't need this, I guess. We can use testing allocator. So we can do var const p is create packet std.testing.allocator and lengths you can content create a struct where its fields depends on the type itself. So this is .name equals name.len .label equals label.len. And then we need to be able to say, yeah, how do you set then this value? Because by the way, create allows you to create an empty one, but then you have to set it. And right now setting is not great, isn't it? Setting it, it's definitely not great. Packet name.init. Yeah. We're missing some sugar, I think. Because of our wacky API, we're kind of missing some sugar. It feels to me. I mean, we could instead of packet name.init, we could give p a init method. No, we can't. We can't give methods to p. That's the point. We don't control that. That's actually what we want. Yeah, I can do that to flexible array, but not to the parent struct. Like I can't give methods to packet, or rather, the who controls packet can do that. But yeah, you can wrap p in your own struct. Yes, but we were trying to avoid that a little bit. Although maybe we shouldn't. Maybe we could create a wrapping type just that only contains convenience. Let's do it a little bit manually just to test that our stuff is like the basics are working correctly. So let's do we have p, so we can do p dot what was it, id hash. Then we can set p dot name, or we can do p dot name dot set, I guess. I guess we can do this. So we're missing set. I think it's mostly the same, set and get. I don't know why they copied. I think it's literally one a function of the other. So const slice equals it's t and then bytes. Actually, more than value is values. Do you set everything all at once? I mean, no, that's a peculiarity of strings. This is like the string is kind of like this weird thing where many items are one item. But like if you had a list of structs, do you necessarily want to set all of them? Sometimes, yes. I guess, yeah, this should really be init, shouldn't it? Init, and then this returns void, and then values is a slice of t, and then we basically want to do a mem copy on the slice. So we do f the slice, and we get an s, and then we assert that the length are the same. But I think this is basically what mem copy does. It does assert, doesn't it? Have you seen the example of Rax? No. Oh man, this is kind of unreadable. Could you paste this on Zigbin if you don't mind? No, there's something wrong with what we're doing. So here's the problem. We need to write. But we don't do this. We can't do this because this needs to be already set. So when we creates an instance, sets all flexible array len fields to the correct value. So we do this. Rux node is key false. Bytes equals null. Pointers equals dot init. No, the problem is that you cannot do this. Let me think about it for a moment. So this cannot be this because this needs at the very least a pointer to where it is in memory. Yeah, also this dot init, for this dot init to work here, I think it wouldn't have to be, let me think about it for a second, but I think this would have to be an init that doesn't accept like a self parameter. Our init, we need to do f.init, not like a field instance.init. We need a pointer already to it. I don't think that syntax is possible to make work with what we're trying to achieve. I think that this len field here is also misleading. I think it should be like len type. What is being attempted here? Here's some context. Take a look at this thread. I probably gave you a link that scrolls you down. Go all the way to the top and see what's there. That's basically what we're trying to do. So we need to cast this to we need to do this, the opposite of this, right? Where is it? We want to take this pointer of bytes and turn it into a pointer to p. But we'll see later. Zig will tell us if this works or not. And then we need to do this. We need to loop again. And this time we don't need this check because it already worked. And then we need to do this. We need to do add field p field.name. Actually, like this, add field p comma field.name .len equals this. But we cannot do this for voids, which makes that problematic. But it's fine. So I guess it's like this. If field dot type dot child is different than void, then we do this. And if it's void, there is no safety. Void fields, we cannot give them safety. We can do if len or void is different than void, then we can do this. We can assert that f.len equals values.len. Again, length typoed. This assert is this assert useful? It's not really. Or no, wait, let me think about it. I mean, it's kind of redundant with what memcopy does, I suspect, because I think that memcopy asserts this. Let's see. This must be a mutable slice, mutable pointer to an array. Source must be a slice, blah, 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 blah. I may have any alignment, any element type. Source element must have the same in-memory representation as the destination element type. Similar to for loops, at least one of the source destination must provide a length. And if the two lengths are provided, they must be equal. To be honest, that's basically, we can leave it as this. And if this guy returns you a value that doesn't that doesn't have a length, then this will still work because values does have a length. Okay, this is actually fine as is. I mean, it gives you as much safety as it can reasonably give you. Okay, I think it's time to try it out at this point. Let's see how it goes. So let me just double check one last time. We pass in these lengths and create writes them down for us. It does, and then it needs to return p. Actually, data. Wait, actually, what? No, it's p. Oh, actually, we needed to do the cast anyway. Okay. Now let's go through all the errors. The following command terminated unexpectedly. Uh, what happened? Where where's my error? Like wait, so we failed to compile, and I'm totally fine with that. But what happened? Bro, please. Please. Zig test source slash root.zig. Life ruined. Life completely ruined. Which zig do we have? Oh, we have the new stuff. So okay, let me try to make this a little bit better. Instead of an enum literal here, I think we can accept a string. Let's see what happens. So no more tag name, just the name. I knew it. That tag name was trouble. Oh no, never mind. I think it's worse than that. Sorry, we're not yet out. We're not yet out. That's unfortunate. That is unfortunate. Pointers, not bytes. Oh yeah. But this is not what's causing the crash, I think. Well, this is sad. Is this the end of our adventure here? We got so close. And we actually don't even know where the real problem is. Is it create? I think we might be just a little bit too loopy with this stuff. Let me see what's the loopiest thing that we're doing. Also, you know what? While we're at it, let's change this into something better. Len type, and then this is a type. Let's reward also the docs. The integer type to be used to store length information for the flexible array. To make the flexible array not store length information in the struct, use void. Note that only the last field of a struct can yeah, I know, I'm doing it all the time. Additional type uses length information for the flexible array. To make the flexible array not store any length information in the struct, use void. Note that only the last field of the struct can have void length type. Set to void. I guess we can do this. Use full word. Yeah, that sounds fine. Okay. So by the way, I was wondering, why is ZLS so silent? ZLS is silent because the Z compiler is turbo crashing in the background. That's what's happening. That is what is happening. And at this point, we don't need len or void. We do need the checks though. What happened to the Raytracer? I'm done with it. I completed it yesterday. I pushed everything to GitHub. If you go to my GitHub profile, it's Christoph-IT, and then there's ChristRTX. That's the repo name. You will find the latest version of everything that I've done, plus links to YouTube recordings. Hello, Rever B Addict. Are you? Wait, are you Tristan? Are you this Tristan? Are you him? Oh, there you go. Hello. Yes, so we made progress. Here's the problem. This looks really cool, but the problem is that we are causing the compiler to crash. Our metaprogramming is a little bit too loopy right now, and we're stressing a dark corner. Yeah, detective agency received a new case, pretty much. It's kind of sad. Let me double check that everything works. Okay, let's see if we crash again or if we have compile errors this time. No field name len. Yeah, we need to upgrade our tests. I don't think I have a command for that. Oh, come on. Did I typo it or is this case sensitive? There we go. Length type. Oh my god, did I typo it? Man, I turbo typoed it. Every single time I wrote it, I typoed it a different way. Yeah, there we go. We're back to segfaulting. We segfault in the compiler. And yeah, that's sad. So, well, I don't have a stack trace because I don't have a debug build of the compiler. I have a release build of the compiler. So I am mourning. Well, I'm mourning the segfault. Okay, let's double check. In any case, so Tristan, I don't know how much you saw of the Radix 3 use case. It's It's a use case that I'm familiar with because I've implemented Radix 3 a couple of times in the last, I don't know, 5 years. So it's not like I'm super, up to date with this, but I've done it. So I have a good memory of how everything works. And the core point is that you need length information of the various slices to be in the node. Like step number 1. And then the point number 2 is then you would be nice if you're able to get clever with it. Feels more like a multi-array list, but I don't know what to do with that thought. Yeah, I think more importantly, I would say this is not even that, because I showed you that example, but in reality with Rax, you want to get even more cleverer than that, because let me show you. Well, thank you, GitHub. You're a genius. So this is one layout, but there's another layout where you have nodes in a Radix tree can be a sequence or a branching point. This node structure is a branching point. There are multiple characters that you can choose from when matching your string, and only one of them is the one that you want to match. So like it's a branching point. And so you say, oh yeah, I have my next letter is going to be Z, so I'm going to go to the Z node and continue matching. But then you have this type of node where instead the letters are a sequence. It's like a substring. So imagine that you have in your Radix tree cat and caterpillar, so CAT, then it's one substring that will be stored in a single node like this. And look what happens. What previously was meant to be this is now this. It's basically many letters, but then one pointer. So my point is this. In reality, what you want is just the ability to decouple the two things. And then how exactly this is managed? The two things, I mean, like the byte thing, like the buffer in memory and its length information. And then once you decouple them, then it's up to the programmer to decide how to derive this info. So one specific way in which you could do this is this, which, as you pointed out, is, similar to multi-array list in a sense. But this one is not. And in my mind, this should be modeled as the same as, when you have tagged unions and non-tagged union. A non-tagged union basically means that it's more unsafe, which is also the case here. But it also means, well, then it's up to you to decide how to derive the tag information, or more precisely, what is the active case. So here's how I designed it here. The idea is when you define a flexible array, you specify the type of the element of the slice, and then you have options. And the options are the parent type, the name of this field, because we need this information because we don't have a wrapping function, so we only see our own type definition. I'm going to show you an example down below. And then the type that we use to store the length, with the assumption that if you have a void type, then if you pass void here, then the idea is we do not store length information, then it will be up to you. So when you put this to void, slice doesn't return you the slice function does not return you an actual slice, but it returns you this. It returns you a many pointer. And then you as the user have to figure out exactly how to know how long it is. This also, by the way, opened the door to the idea of having null termination, like supporting null termination, but for now I'm not doing anything with it. So I'm ignoring that problem. So what is interesting about this? So what is interesting is that then basically we create this. Okay, let me update this syntax. So this is gonna be, I don't know, U8, and then these are the options. is this. Dot name is this. And then dot length type is this. And then this can be something else. USize. It's an array of USizes, for example. Okay, give me a sec. I'm updating this example. Okay, so this is how you define this. For example, you have some fields, then you have your flexible arrays. This one is usize, this one is void. So the idea is that then the memory layout is going to be this. Bar is going to be a packed struct that contains a length field. And buzz becomes a packed struct that contains a void field, which has size 0. And the idea is that I'm not doing it here, but because I'm also thinking about the Rax use case, with this approach, we also support packed structs correctly. Because we, so far in the design, we unconditionally generate packed structs in here, which should be fine. Because if your outer struct is not packed, then that's fine. We can have this packed. Like it's a little bit of extra useless indirection, but it's fine. Well, although not exactly useless, because this is what allows us to have slice in here and in here. And then if you don't have a length, then len is going to be a void field, doesn't occupy any memory. And it also gives you a nice type error if you try to use this len field expecting it to be an actual number. It would be maybe even better if we could take it out, but we can't take it out because then we would lose the ability to define decals on these types. So, so this seems cool. This seems cool. If only it didn't crash the compiler. I suspect that this might be the problem, though. Let me try this. Let me fix stuff. And this, by the way, I was scouting for loopy things that I was doing, and now that I think about it, sorry, not any type, any opaque, and I think that this pointing at this is what's causing the crash. Wait, is len an actual field on the return struct, or is it the fake field used with pointer arithmetic? No, it's real. It's a real field. Because in our case, well, with this design is meant to be different than yours with obese slices, with structured slices. The idea here is that the length has to stay in the heap memory to support the use case like Rax, for example. And so because of that, I can put this in the struct definition. And it will work. Whether that breaks .auto structs, in which way? Yeah, it will get moved around, but it doesn't matter because we still act, because since it will, even though it will be moved around, we can now access the len information by doing field, by doing at field of struct and the field name. So the metaprogramming will adjust any offset accordingly. And it doesn't matter. And then the tail afterwards, like with the rest of stuff in memory, will follow the order definition here, which might not match any potential reordering in here, sure. But it shouldn't be a problem. So maybe I can show you even precisely where I'm doing this. I'm looping all fields. If I encounter a field that is not a flexible field, I ignore it because I don't care. So as soon as I encounter a flexible field, this is how I grab its value. And then I look at it and I say, wait, is this ourselves? If it's not ourselves, so imagine that we're scanning, all the ones before us, then let's skip this if for now. We go down here and we literally do value.len times the size of the child type of that field. And that moves forward. I'm not accounting for alignment right now. I'm missing alignment math. So then we keep looping. At some point we encounter ourselves, and then the question is, okay, we get a mini pointer to our items based on the offset that we accumulated up until now. And then we say, wait, are we a void slice? If yes, then that's what we return. If not, then we slice again. There are comp time force at the end of the struct. What specifically? The len field or the buffers? The void one, yes. The void one has to be the last one. Because if I put a void one in the middle, then I don't know how to calculate its offset, right? Or I guess I could come up with some complicated way to have the user provide this information that we're missing, but it seems a bad idea. So the assumption is that the only flexible array that is allowed to not store its own length information is the last one. So that for us, computing offsets is feasible. There's a non-flexible field after the flexible field. Oh, you mean in the struct itself? It doesn't matter because our offset starts from the end of the header. So we don't care about that. So we skip the size of the struct itself all at once. And then we need to, the only thing that remains for us to count is the actual slices in memory. And so we only do counting for the slices in memory. I could not skip flexible. I could start at offset 0, right? We start at offset 0 and then we actually do count everything. But you can do everything in one go. It's less metaprogramming. Just skip the header. And this works if you conceptualize this like this, right? There's a header, and then you have all the tails afterwards. Yeah. I do think that in your case, probably with structured slices, I don't know this for sure, but I suspect that trying to support flexible array fields that do not have their own information, that do not have their own length information, is probably superfluous. And I would say there's probably no advantage to that, or I cannot say this for sure, but I can't think of a use case where that would make sense. Because so far, the only use case where this seems particularly good is one where, in any case, we want length information to be stored on the heap, not in a slice. So unless you can find a use case where you want length information in the slice, and you also have a good reason to want to skip some length information, then that's fine. But otherwise, I don't know if it's worth it. Because it's a bunch of extra annoyance. Yeah. And also, you know what this made me realize? That in reality, even though both what we're working on, like you with your implementation in this one, which by the way, I wrote this already, but just for, I don't know, people watching, this original design is from Andrew Krajewski. I'm just like polishing it, but he was the one who came up with this idea first. In any case, what I wanted to say is that in reality, if you think about it really well, the C flexible array feature is an array that does not store its own length. So what we are doing with everything like this, what you are doing and what I am doing with this is not a flexible array member in reality. This one is a flexible array member, following the C definition. Like if we try to follow the C definition like to a T, this is a flexible array member. This, I don't know what it is. You could maybe reuse the same concept and kind of conflate the two ideas together, which is what I'm doing here, for example. But yeah, that's something that came to mind. That said, if I had to come up with a better name, I don't know what better name I would use. I do think that flexible array is better. Like in both our cases, flexible array is better than VLA. I think. You know what? Actually, I'm not sure. I genuinely don't know at this point anymore. At this point, I genuinely do not know. You know what? Actually, maybe the correct name for you is slice, because what you create is truly a slice. There's some memory, or like a contiguous slice or a slice segment. I don't know. Maybe you can get more clever, but you really are creating a slice. This guy is a slice. This is some memory and then some length stored somewhere. I don't know. Sorry. Tail slice. Yeah. Tail slice is cool. Inline slice. Yeah, mine is more of an inline slice than his. Tail slice sounds cool. Yeah, it is. It is a tail slice. Yeah, that's actually a very good name. Yeah. Yeah. And I mean, you have a structured slice that contains a bunch of tail slices. That makes sense. Yeah, I wish that this didn't crash though. Okay, let me fix the code, because maybe the one loopy thing that I was doing is this, and undoing this saves us from the crash. Let's see. Actually, you know what? For dramatic effect, I'm gonna do this. I'm gonna keep passing in at this, and then we fix all compile errors until we get a... Okay, we're already at the seg fault, but I want to make some changes. Then after I make the changes, let's see if we crash again, and then let's try to uncrash ourselves by looking at the instantiation code more than the generic code. So this is what I want to do. So I was moving away from having these things. So let's refactor this a little bit. So here we need to do this. If so, we need to len info. Let's call it len info. Okay, and then we do if len ops.length type is void, then we do the void checking. Else, if, and then we do len info different than dot integer, and we have the other check. So this is where we complain about not being an integer type or void. And here we complain about not being last. And this can go away. Okay. Let me double check. So if length is void, then are we the last one? Oh, wait a second. What the fuck am I doing? Yeah, check this out. Oh, wait a second. I'm doing something dumb. Look at this. This is not this. This is wrong. These checks go inside. Well, there is a this. It's the outer struct, but with the top level namespace. But yeah, in any case, that's not what we want. That's for sure. So comp time. Yeah, this needs to go inside. Can we put also this inside? So now this is correct. Then this is len or void. Okay, we're back to crashing. Now, let's see if this solves it. What if this becomes a pointer to any opaque? We still crash. Okay, so this is not it. Let me comment out this test entirely. Now we don't crash, but we have a problem. Struct packet depends on itself. That's not exactly true. Come on. Come on. We were able to do this actually. So we know that this can kind of be done because, well, it kind of makes sense. But also, wait, lang. Okay, one sec, because I think I'm going insane. Oh, length GH. Oh my god. Yeah, this still does not solve it. So here's the thing. What if this was not packed? Is packed what's causing Zig to freak out? No, it's not packed. So now we have the problem that now this says that struct packet depends on itself. You know that it might be this. I fear that. Oh, you know what? This is one big change that I made compared to the original code from Andrew Krevsky, and I bet you that this might be it. What if this actually starts at 0 and we do wrong math? We still depend on ourselves. So this is not it. So what else might be causing this? Comp time options. The fact that this, well, let's try. Yeah, but I don't think it is. Yeah, no. I think also the fact that it has this type here makes it comp time by default, I think. What else are we doing? Let's take a look at the original code from Andrew, because that one was working. What did we do that is new? We loop over all fields. We do some bit casts. Oh, you know what it is that we're not doing? we are not trying to access a child decal into the other from other fields. Here we are assuming that everything is a U8, so we're not trying to grab T from the other decals. That might be what it's causing us to fail. This is more specifically done here. So this is where we're doing it. We're still depending on ourselves though. And in any case, we're doing this. Yeah, to be honest, it's not like we're doing anything particularly weird. Yeah, so this is not it either. Oh. Here's another difference. He has this definition outside, not inside. That does not change anything. Okay, what else can we do? We have of P. What if instead we did 1 here? Yeah, that's not it either. Oh, we have this. Wait a second. Oh, but this is create. Wait, what am I doing? Create is fine. Create cannot be the problem. I think actually. Yeah, this it's definitely not create. And it shouldn't be able to be create. Okay, to continue testing, let's comment out some checks. The checks are not what are causing this. What if we comment out init? It's not init. Well, what if we didn't do this? We haven't used variables. Yeah. And use local constant. Variable of type comply int must be const or comp time. Has decal length expected type. Oh. Length is missing name. Length is missing name. I'm dumb. It's not has decal. It has field, and I guess it can be type of. Expected pointer type. Found error out of memory. Okay, we're fixing a bunch of programming errors that I had. No function name set. Yeah, it's init, which we have fully commented out. Let's uncomment. Expected type U8 found blah blah blah. Expected equals license method const U8 found consequence blah blah blah. Yeah. Start flexible array does not have child. Yep. Let's comment it out. Source and destination arguments have non-equal lengths. That is correct. Okay, that is correct. Can we re-enable comp time checks? The comp time check is enough to make this poop itself. Let's remove the comp time check. Okay. No comp time check then? Can we re-implement the logic? At least some of it. Local variable is there mutated. Okay. So this is working. But I think the problem is that because of p info fields, this is going to poop itself. Can you run comp and check into a struct echo? It is. It is in here. I assume anything outside the return struct is getting evaluated immediately versus deferred if behind the return struct. I wouldn't say so. Or rather, there is probably an order between these things, but not as in like explicitly different stages that you should be able to observe as a user, I believe. That said, we can do this for sure. We can take this stuff and move it down. So we can put all these decals in here, and well, we can put return type in here, and then this we can put in here. And see what happens. Christopher IT, I just got my intern in Cisco Systems. Why no one told me how toxic could the senior devs be? It makes me feel like shit. So what you're saying is that you got your internship in Cisco systems. So you're being an intern there, and well, no one told you how toxic senior devs could be. Sorry, I don't know exactly what your life experience is, but it's not exactly a secret. Then there are certain kinds of like developer circles where kind of being an ass is considered the norm. This is kind of true with people that do not necessarily entirely true, but it's not something that should surprise you when it comes, for example, to people that do systems level programming like C and C++. Again, it's not a judgment of of the totality of developers that use these languages. It's not even a judgment of the language itself, but it is true, for example, that there's people that do OS dev in C++, and they're not considered to be the most welcoming people. So, and I don't know specifically what kind of people you're dealing with, because I brought up this example, but you can find similar examples also in all kinds of like, let's say, sub industries, like chunks of the tech industry. I don't know if they're trained to do that, but anything they do, they try hard to make it seem not enough or wrong in some way. Mm-hmm. I just wasn't prepared. Here's my suggestion. This is generally the best suggestion I can give you, which, it's not necessarily a particularly good suggestion. That would be for you to evaluate, but it is the best that I can offer you. There's a page for this. This is the best that I can offer you. The title might make it sound like I'm saying, oh, you might have imposter syndrome and that's why you're having these issues. No, don't let the title trick you into coming to these conclusions. This talk is about more than that. And it also contains suggestions on what to do when the people around you are asses. Okay, so let's fix this code and see if we're making any progress. And use local constant bytes. How does this work? Cannot infer length of slice from any pointer. Yes, so this is the case where we might be interested in doing one thing or the other. So maybe we can then uncomment a little bit more stuff and restore some more functionality. So this doesn't seem too bad. This seems fine. Yeah. We're seg faulting because I'm passing bogus data. But we're slowly restoring functionality. Now watch this be the problem. Okay. We're compiling. We fixed pretty much all of it. We don't have these checks. Yeah, the test link memory. Well, why can you do such as live? There you go. Defer std testing.allocator. Oh, snap. How do we free this? How do we free this bad boy? Oh no. Well, okay, it has to be like this, right? We need to do we need to have flex.free, which is more a destroy than a free. Destroy GPA packet, and this also needs to give us potentially the length of the last field, optionally the length of the last field, which in our case, do we have any so we can pass null? I think that's how it has to be. Okay, let's implement destroy. So we fixed our stuff. We need to understand what to do with this, but we got out of the metaprogramming issue. So also, can I define packet back inside of here now? Let's see, what are people saying? Programmers are, yeah, they're not disproportionately. There's no a massive disproportion of people being asses in tech than outside of tech. That's for sure. But within tech, you have, I think, bubbles where sometimes you have people that are generally not asses, and sometimes you have bubbles where people are generally asses. Setting aside things, how can I say? So while it would be reasonable to be skeptical of any statement that I make about the Z community, because obviously I will have maybe reasons to want to sell it as better than it actually is, or I will have a perspective that is distorted from reality because of, I don't know, the nature of my involvement in the Z community. And to be fair, nobody knows anything that complicated fully. I don't know the Z community in its fullness. I only know a fraction of it. That said, I do believe that I know a bigger fraction of it than almost anybody else. It's my job. But I do believe that one of the reasons of Zig's success is trying to have a community space. And I'm talking, I think this is generally true, but it's true in different ways when it comes to, for example, the community, let's say at large, like people doing making projects with Zig. And in a different way, I think this is true when it comes to people working on Zig. And these two, let's say that these are two groups for the purpose of what I'm trying to say. And these two groups are different. They have different standards of communication and different ways of approaching. But I do think that both are what they should be in their own way. So generally speaking, if you don't know how to do something when it comes to manual memory management or systems programming in Zig, and you go ask in a Zig community, I'm thinking of Zigit, for example, or the Discord server, maybe you will not get the perfect reply right away. Like sometimes you get people that actually know what is the right answer. Sometimes you don't. And obviously it would be better if the people that give answers know what they're talking about. But the bigger the community, the harder it is for that to be true. So, it's something that you try to make better, but then whatever happens in any specific instance. But in general, people will give you answers. They are not going to tell you, "Oh, you're dumb. How could you not know this?" They will take the time to explain. Maybe they won't take the time to explain, but they will link you to a previous explanation. So, like, if you're the 10,000th people that asks the same basic question, at some point, people will refer you to pre-existing materials. But they do this. They don't, shade on you because you don't know stuff. Then when it comes to people working on Zig, this has to be different because working on Zig to allow the project to make progress, you need to be more restrictive with the type of conversations that you're willing to entertain. So, for example, sometimes there's people that come to Zig, they come from, let's say, C#, or like another language where they're used to a different way of doing things. And to them, that's the natural way. And they come with these ideas in their mind, which are not necessarily wrong, but they come from a perspective that is, at the end of the day, naive compared to the perspective that somebody who has been working on Z for like 5 years will have. And also, they will not know anything about lower level programming, and they will have, certain perspectives that, as I said, are ultimately a little bit too naive. And those will be discussions that do not really get entertained much in, for example, the ZSF Zulip. So that, I think, would be, if the rest of the Zig community behaved that way everywhere, I think that would be bad. But this is kind of necessary for the ZSF Zulip to actually be focused and make progress, because otherwise you're going to be bike shedding forever about basic stuff forever. So this is necessary. But at the same time, when it comes to, once you have a critical amount of knowledge where your opinions are not naive anymore, then you can participate in the ZSF Zulip. And of course, some of it boils down to, and the preferences that Andrews has. So I guess I'm not trying to say that Zig is, the ultimate perfection when it comes to technical discussion, but I do believe that it's very high quality. And I do think that, sometimes people ask, how did Zig become popular? This is one very obvious and like in your face, like trivially observable property of the Zig community. And in fact, whenever somebody asks me, wait, how did Zig become popular? I never want to answer the question. I always give stupid answers because I feel like that if you are asking this question, it means that you're not able to see and appreciate the obvious things in front of you. So there's no point in me actually telling you. This could almost become like a Zen story, like the blind man asking what is in front of them, and other people refusing to give them an answer because, look, if you can't see what's in front of you, like me telling you is not enough. You need to be able to appreciate it yourself. Man, so many comments. Okay, what did I miss on? I'm scrolling fast. Sorry, guys. I'm assuming that you guys are having a good discussion on your own, and I don't need to reply to every comment. Skip. No, I'm scrolling to see if there's anything that makes sense for me to reply to. Okay. Yeah, we got ourselves out of that crashy rabbit hole. Isn't this an Anchorman quote? Oh, I don't understand it, and that makes me angry. Yeah, about the tone of the feedback. There is certainly something. Sorry, I don't know if you guys can hear that. There's like a car beeping in the background. Hopefully, it's not too distracting. Yeah, about the tone with which in which people give feedback. I agree that. Yeah, when you are in an ecosystem where you're not required to reply to somebody else, replying in a bad way where you have an annoyed tone and you call the other person names, like you say that they're dumb because they don't understand it, and so you're not really giving an explanation, that to me is a pretty much instant ban. Because well, maybe not instant, but let me bring up what I mean. I have this rule in my Discord server, for example. So I'm gonna read them, and then I'll read up to the point where I get to what I was referring to. So no water cooler complaints. You're allowed to complain about something in direct proportion to how much work you're doing to improve said thing. That's a nice rule for a community. That's why it's rule number 1. The best opinions come from first-hand experience. You need to write Z code to have an opinion on Zig worth listening to, for example. The stronger your opinion on something, the more thorough your arguments need to be. A discussion is only worthwhile if both parties get something out of it. Preferably something that leads to better practical outcomes. Discussions made only for the sake of debating constitute misuse of the communication channel we're all sharing and thus are ban-worthy. This is what I was referring to. So if you're in a situation where you could very well not have a bad exchange and you willingly decide to get yourself in a bad exchange, like it makes no sense. You're being dumb. You are misusing a communication channel that other people share. So I do strongly believe that this should be ban-worthy. It doesn't necessarily mean that the first time somebody does it, you need to ban them, but it is bad behavior that should not be tolerated. That said, it should be said that when it comes to your job, like your day work, you're not exactly in the same context. You are in a context where sometimes you are forced to do something that you don't want. I mean, the whole point why people are paying you to do what you're doing is because you wouldn't be doing it otherwise if they didn't pay you. So in your workplace, there is some friction between colleagues that you kinda can't get out of. Sometimes for your job, you have to communicate even if you don't want to. So in a sense, this is different, right? This still applies, obviously. Like the fact that you are giving a annoyed reply to somebody and you're like wasting your time and their time, it's still a bad situation. But the difference is that in a community, in open source, when you get into these discussions, it's entirely your choice. In your workplace, it's not entirely your choice. And the fact that it's not entirely your choice is the thing that probably contributes to people getting, annoyed over and over at the same situation and then eventually fed up and then eventually explode, for example. Especially if your workplace has one of those cultures where you have to sound nice, right? Up until you explode. What is the solution there? I don't know. I think that the best solution at the end of the day is to just find a job where you can interact with people that you can have good interactions with. Obviously, this is not a luxury that everybody can afford because you need a job to eat and pay rent. So sometimes you just can't job hop until you find the perfect Goldilocks job. But you do have, especially in tech, I think, enough flexibility to be able to change jobs over time. I mean, on average, what is it, 2 years that software developers change jobs? So you should be able to do that. But yeah, in any case, life is hard. And yep, not taking it out on other people, usually a good idea. So we don't have destroy. Let's implement destroy. So destroy. GPA P. Void len. Optional usize. Okay, let's give docs to our stuff. Well, GPA hopefully is clear. Pointer to a pointer to an instance of a struct that contains flexible array fields. If the length of the last flexible array field well, no, let me put it this way. If the struct has a flexible array field that has length type set to void, you must provide its length. Pass null otherwise. Let's see. I'm new to watching coding live streams, but struggling with not being able to view your code in my editor. Yeah. Okay, I think this is destroy basically. So what do? We need to basically turn this pointer to a struct into a pointer to bytes. That's what we want. So we need to compute size. Var size usize is size of p dot star. Oh no, that does not work because it needs to be type. Okay, add type. Okay, so let's start, I guess, with validation. The type that we need to be passed in is a pointer. By the way, we are seeing right now that this API has so many words because we don't have a type that encompasses the whole struct. We're only generating fields, but the fact that we don't wrap it in anything, it's making us suffer so freaking much, man. It's really making us suffer too much. Imaging is less of flexible arrays. Oh god. Okay. So we want the struct type, which is P. Okay, P info is at type info of P dot pointer dot one. Actually, pointer might not have one. Also, I think these are all lowercase now, so this is pointer, I guess. So we can put this here, and then this is size of the info.child. And then we need to do the loop stuff. So we loop on. Oh, we can do dot pointer dot child, I guess. Yeah, there we go. That's actually not bad. Although this is P. Yeah. Okay, if it's not flexible, we skip it. If it is, then we want to add its length. So if child is different than void, we do size plus equals. Oh, what am I doing? This is actually what I want to keep. Yeah, we add the length stored in there, and then if it is void, then what do we do? We kind of need to. So the point is that we also want to have like safety about around this and say, look, actually, if you give me a type that doesn't have void, then having a non-com time, like specifying void len, is a problem. Which, by the way, there's also another way of specifying this, which is kind of funny. Hmm. Let's do this for now. Then maybe we can iterate on the API later on. There we go. And we can also do this. If built-in dot std debug dot runtime safety, we can also do this. If void len is different than null, then assert you know what? Okay, we can add this check later. Okay, let's get this working. In any case, we computed size. Then we do const bytes equals we pointer casp to that, and then we do GPA dot free bytes 0 dot dot size. That's it. Unable to resolve comp time value. Unable to resolve comp time value. Type info type of B. No field name fields in union built-in type. Okay. Allocation alignment 8 does not match free alignment 1. Yeah. Success. Okay. So it seems that we're doing it right. At least with this simple test with bytes. But we have it. The API is, well, it's certainly something. Let me just say this. The API is definitely something. The API is something without a doubt. But I think we now have some of the pieces. And I guess next we need resize and realloc, maybe. Because the most cursed zig you can write. It's not that cursed. Come on. It's unfortunately not able to do safety checks of comp time metaprogramming right now. That is kind of sad to me. I wish these were better in that sense. I think it might be just int. Yo, that works. And guess what? P-info being out here was the problem. Yeah. We needed more local P-infos, apparently. Mm-hmm. No, it's not just that. I might be wrong, but I don't think it's just that. Let me put this here and let's see if that makes it any better. It works. I think you're right. I think the problem was in the end that one. Huh. Okay. Okay, so now we have some nice comp time checks, which we can't test, unfortunately, because we can't test for expected compile errors. Or rather, we can if we want to. It just needs to be a different type of test. It can't be a unit test. It needs to be a test that's orchestrated via the build system. We have creation. We have init. Init is nice because in safe modes will also save us from mistakes. Let me give you an example. Here I give name.len +1. Look what happens. Oh, what should happen? Yeah, there we go. Panic. Source and destination arguments have non-equal lengths. And we can even add a comment so that we make this more explicit. So this is the part that the line that panics, and we say values has different length len than the allocated memory. Okay. In any case, I clearly don't know enough about compiler internals either. I did expect this to not make as much of a difference, but it does, and that's probably actually fair. Like, you know what? I suspect that your intuition was on point in the end of the day. Okay, so to be able to do racks, we need to implement more stuff because we need to be able to mutate these guys. We need to be able to mutate them. There's also another problem here where the problem is that with this setup, we cannot allocate memory. We cannot allocate more memory than what we strictly need. And so every time we want to add one element, then we need to resize the memory. And that kind of sucks. Because you can't, like, we would like to have a amortized array list behavior. But now that I think about it, with this setup, we don't have the ability to do that because we don't have a concept length versus capacity. But I think that this actually is a flaw also in the original design now that I think about it. I can double check, but I don't think that Rax is able to like pre-allocate using a non-linear growth strategy, which is not something that you would necessarily want either, to be fair. To be fair, usually with this type of data structure, you don't want to... Still not quite sure what Rax is. This is Rax. But so you have bat, cat, coat, cats. And so a Radix tree would be like this. You have $, which is like, let's say empty character. And it goes into B, A, T, goes into C. C goes into O, A, T, which goes into, let's say, line end. Actually, I think these are swapped around. Maybe this is line end, the beginning, and $ is line end. In any case, you have like special symbols to define. These are special symbols. So code, and then here you have A. Actually, I'm wrong. You have AT, which goes to $, whatever. This is like a AND node because it's a key. You know what? I shouldn't have done this. It's irrelevant. What's relevant is that this then goes to S, which I guess we can make it go to $. So you get the idea. Yeah, it's a tree that collects unbroken sequences of characters into a single node. What is the problem though? Let's say that we now add coin, okay? Because you build these trees iteratively, and or rather, I guess you could make an assumption of a one batched build, but normally you want to be able to mutate them at runtime. And so let's say that at some point we decided we want to add coin. Well, adding coin means doing this. You see how we have code, right? We have C and then oat. Well, this has to go away. And this needs to become just O. This has to go away. Where is it? And so now you have to split this. When you add words, you always reduce node size. With the way I'm drawing it here, yes. But in reality, no. Because in reality, what happens is that the way it works in racks is that what you do more precisely, this is what I'm showing you right now is conceptual. What happens is actually something more like this. O doesn't have its own node. O goes in here. It's CO. And here you have A or I. And then here you have T and N, with the idea that these lives inside a single node, and you have these two letters, but that are in a OR relationship, and for each one of them you have a pointer to the next node, and you can see this explained here. This is an example where you have A or N, and then you go to different pointers. And lastly, if you support deletion, then you also need to be able to, basically do what I just described, but in reverse. So now you need to be able to grow nodes. Also, yeah, does this guy do any kind of clever allocation strategy? I do not think it does. Realloc for data. Realloc the node to make room for auxiliary data in order to store an item in that node. On out of memory, null is returned. Rack's current length. Yeah, it literally calls realloc plus size of. Although this is just to store data, so that's fine. Set data, get data, add the child. Yeah, new len. What is new len? Yeah, it's literally current length, size plus plus, call current length again, size minus minus. What is going on? For now, restore the original size. We'll update it only on success at the end. Oh, okay, so this is also dealing with potential allocation failures. This is cool. But also, it's interesting how doing size plus plus requires recomputing things, because I'm guessing that doing size plus plus doesn't necessarily just add what you want. It can add more than one byte. So it needs to go through a function that computes length, and then it calls realloc on new length. So this data structure does not grow super smartly. That said, it doesn't pay the price for having a capacity counter. Would the capacity counter be good to have? Maybe. Maybe yes, maybe no. In any case, so here's what I think I'll do. I think I'm going to call it a day. I would say that we did a good job at a first stab at this problem. I'm going to push this in any case, in case that anybody's interested. And then we can see what happens. Oh wait, this is Zigrax. Who cares? Okay. Let's see. What if instead of capacity counters, you make double null terminated strings? You have used part of the buffer, and you know its length. But to know capacity, you go outside of use space and find first zero. No, I think you would probably want to do the inverse, right? You use size, like you use your array field, your struct field to store the capacity, and then you use null termination to know up to which point you filled it. And then every time you want to add something to it, you on your end, like double capacity manually. That's how the way I would do it. And in the case of a Radix tree, it is reasonable to use a null byte as a null terminator. So that's not a problem. You know, there might be some other data structure where you're not dealing with just bytes, and you don't have the luxury of having a null terminator. But I think in Rax you could do it. You know, that actually could be a very cool addition. At the end of the day, what it is that you pay for, you literally pay for 1 extra byte. And then once you're done building the tree, or you know, whenever you want, you could have a function that you can call to say, okay, now reduce the size of every node to exactly what it needs. Like make it more compact and reduce memory usage at that point. It would probably be pretty cool. Okay, so as I was saying, I think I'm going to stop here. We made some progress. We have a first stab at ZigFlex. I guess the next point is continue implementing this. Add the missing parts. And then start using it. And then there's one last question in terms of design in my mind, which is, would it be a good idea instead of having an API that wraps the entire struct? Maybe it would be worth it. Maybe not. It would be worth it potentially from the perspective of creating less code load when it comes to these flexible arrays. But I don't know. Because and you know what? Actually, in any case, these flexible arrays, this stuff can be type erased. If you work hard a little bit, you can type erase these guys. And now that I think about it, you know what? In any case, it might not be worth it, because even if you do type erase them, in any case, once they get resolved, they are so tiny, they do so little math, then you might want to inline them anyway. So I take this back. It probably doesn't really matter. All it does is just slow down comp time a little bit more, because you end up analyzing more stuff than what you strictly need. But it's again not the end of the world. Yeah, I think this is not bad. Okay, so let me see if there's anybody to raid, and then I'm really gonna call it a day. You know what? I'm gonna be lazy. So thank you all, and see you tomorrow. Bye bye. Oh, also tomorrow my talk from System Distributed is gonna premiere, so I'm also gonna watch that. But it's later in the day. It's gonna be tomorrow, 1 hour from now. So in any case, raid Lucas. I didn't see anything. Let's see. Lucas develops. Should we? Let's do that. Go say hi for me.